Assalamu alaikum. Good morning, my dear students. Today, inshallah, we will complete our lesson congruent triangles. In the last session, we have studied two cases of congruent triangles, and we say the first case of congruent triangles is two sides and included angle. And we say that the two triangles are congruent if two sides and the included angle of them of one triangle are congruent to the corresponding parts of the other triangle. As we see in the drawing, we have two sides and included angle C, and two sides and included angle. And AC equals XY and BC equals YZ, and measure of angle C equals measure of angle Z. So the two triangles are congruent, and we see that any triangle has six elements. Uh, and that's and we say that the two triangles have six elements, three sides and three angles. And the triangle is a polygon, and the two polygons are congruent if each element in the first polygon are congruent to is congruent to the corresponding parts in the other polygon, and the triangle are a polygon. So to find the congruent of the two polygons, we should find the six elements and their corresponding parts in the other polygon. But in the triangle, we have a special cases. We have four cases. First case is the two triangles are congruent if we have two sides and the included angle are congruent to the corresponding parts in the other triangle. Second case, it was the two triangles are congruent if two angles and side drawn between them of one triangle are congruent to the corresponding parts in the other triangle. As we see, we have two angles and side, two angles and side. So the case is angle, side, angle, angle, side, angle. So the second case is the two triangles are congruent if two angles and side drawn between them of one triangle are congruent to the corresponding parts of the other triangle. Let's see an example about we have studied. In the opposite figure, is triangle AED congruent to triangle CEB and why? We have two triangles, triangle AED and the triangle CEB. And we have our givens is EC equal and then CEA, and measure of angle A equals measure of angle C. And we say that to find the congruent or the case of congruent triangle, we have three conditions. So with the third condition, we have side and angle. With the third condition, it may be angle or side. If it be an angle, so our case will be angle, side, angle. And if it side, so the case will be side, angle, side. We have two straight line intersect. D, B are intersect A, C line segment. So we say that if we have two straight lines intersect, so measure of angle or each vertically opposite angles are equal in measure. So we have angle DEA. So two straight lines intersect, then angle DEA will be equal in measure angle CEP. So our case will be angle side angle ASA. Let's write our proof. In the two triangles, triangle AED and triangle CEP, we have an AE equals EC, and measure of angle A equal measure of angle C, and DEA equal measure of angle CEB, y vertically opposite angles VOA. It's denoted by VOA. Then what? Then the two triangles are congruent. Then triangle AED are congruent to the triangle CEB. Third case is side, side, side. Three sides, the three sides of the triangle, and it's denoted by S. Let's let's read our case. The two triangles are congruent if each side of one triangle is congruent to the corresponding sides of the other triangle. Again, the two triangles are congruent if each side of one triangle is congruent to the corresponding sides of the other triangle. In triangle ABC and triangle XYZ, we have AP equal XY, and they denoted by the same symbol. So AB are equal in length XY, and AC equal XZ, and CP equal ZY. So the two triangles are congruent. Triangle ABC are congruent to the triangle are congruent to the triangle XYZ. And we say if the three elements in the triangle are congruent to the corresponding parts of the other triangle, so the six elements in the first triangle are congruent to the corresponding parts in the other triangle. So if the three sides in the first triangle congruent to the three sides in the second triangle, so the three angles in the first triangle congruent to the three angles in the second triangle or corresponding parts in the second triangle. So we will find that measure of angle A will be equal measure of angle X, and measure of angle B will be equal measure of angle Y, and also measure of angle C will be equal measure of angle Z. Let's see an example. In the opposite figure, find measure of angle APC. APC, this angle APC. In the two triangles, we have two triangles. In our drawing, we have two triangles. Triangle APD and the triangle CPD. We have our givens is AD equal D equal CD, and the AB equals B C or CB. Where is the third condition? The third condition, we have two sides. The third condition may be angle, so the case will be two sides and the included angle, or side, and the case will be three sides congruent to the corresponding parts in the other triangle. We see that we have DB is a common side. DB is a common side, so the case will be three sides. Let's write our proof. BA equals BC, and BD is a common side. C is common side. It's denoted by CS. And AD equals CD. Then what? Then the two triangles are congruent. Triangle ABD is congruent to the triangle CBD, are congruent to the triangle or the other triangle CBD. We see if the two triangles are congruent, then the six elements in the first triangle are congruent to the corresponding parts in the other triangle. So what? Measure of angle, pay attention and look to the letters of the triangle. Measure of angle A, B, D will be equal in measure angle C, B, angle, give me a second, angle C, B, D. First letter, second letter, third letter. First letter, second letter, third letter. So again, if the triangle is congruent, what? Six elements in the first triangle congruent to the corresponding parts of the other triangle. So angle ABD, where's angle ABD? ABD equals what? Equal in measure angle CBD, this angle. But we don't have the measure of the angle. It's so easy. We say that the sum of measure of the interior angles in any triangle equal 180. And we have in the triangle ABD, we have measure of angle A 110 and measure of angle D 50. So measure of angle ABD will be equal what? Equals 180 minus 110 plus 50, the sum of the other two angles. So it will be equal to what? 150, 110 plus 150 equals 160 minus 180. The result will be 20 degree. Then what? Measure of angle DBC, the greater angle will be 20 plus 20 equals 40 degree. It's so easy. Worst case, and it's just for the right angled triangle. For the right angled triangle, and it's called right hypotenuse side. Right hypotenuse side, or HS. Or HS. Right hypotenuse side. It's just for the right angle, only for the right angled triangle. The two right angled triangle are congruent if the hypotenuse and side of one triangle are congruent to the corresponding parts of the other triangle. But we say we have three conditions in first case. In each case, we have three conditions. Where is the third condition? The third condition is the right angle. Right angle. So the two triangles with a right angle. Two triangles are right angles. So it's enough to find these other two conditions. It will be hypotenuse and side. Hypotenuse and side of the right angle. So the two triangles are congruent if or the two right angles triangles are congruent if the hypotenuse, and we say that the hypotenuse is the side which opposite to the right angle, and it's the greatest side in the triangle, in the right angle triangle. Again, the hypotenuse is the side which opposite to the right angle. Where is the right angle? It's C. So the side which opposite to the right angle, it's called a hypotenuse. It's called what? The hypotenuse. The hypotenuse. So our case will be right hypotenuse side. We have two right angled triangle. So if the hypotenuse in the first triangle equal to the hypotenuse to the second in the second of the second triangle, and side of the right angle are congruent to the other side in the other triangle, so the two triangles will be congruent. The two triangles, since AB line segment is congruent to XY right segment line segments, and BC equal the length of BC equals the length of YZ, the measure of angle C, and the measure of angle C equals the measure of angle Z. The two angles are right angles equal 90 degree. Then what? Then triangle ABC are congruent to the triangle XYZ. Measure of angle, then what? We say that the triangles are congruent, then each element in the first triangle are congruent to the corresponding parts in the other triangle. If we have hypotenuse side in the right angle, the triangle congruent to the corresponding parts in the other triangle, so that the angles, the other two angles and the side will be congruent to their corresponding parts in the other triangle. Measure of angles and measure of angle A will equal and measure angle X, and measure of angle B, measure of angle B will be equal and measure of angle Y, and BC equal, or the length of BC equal the length of YZ, and AC will be equal XZ. Let's see an example. In the opposite figure, find measure of angle EAC. Where is angle EAC? EAC. This angle. Pay attention. Angle EAC is a part of the straight line D or DB, or a straight angle DB. So if we find the measure of angle EA, it's so easy to find EAD. It's easy to find the measure of angle EAC. What is the case of the congruent of the two triangles? We see that the two triangles are right angled triangle. We have two triangles where triangle DEA and the triangle DAC. And the two triangles are congruent triangles. And the hypotenuse in the first triangle, the side which opposite to the right angle, are congruent to the hypotenuse in the other triangle, and side of the right angle in the first triangle are congruent to side of the right angle of the second triangle. So our case will be right hypotenuse side. Let's write our proof. In the triangle ABC, we have measure of angle C, but first find measure of angle C. Let's find measure of angle C. If angle CAB equals 60 and the measure of angle CBA equals 90 degrees, it's a right angle. So measure of angle C will be equals 180 minus the sum of the other two angles, 60 plus 90, it will be equal 30 degrees. And the case of the two congruent triangles will be AC equals AE and AD equals CB, and measure of angle B equals the measure of angle D, 90 degrees, right angle. Then triangle ABC will be congruent to the triangle CBD. Then measure of angle C will be equal what? Measure of angle where angle C will be equal angle A, but where angle A? The last letter. So ABACB will be equal DAE. DAA, this angle. So this angle will be equal 30 degrees. Then what? Then measure of angle AEC, our required will be 180 minus 60 plus 30, it will be equals 90 degrees. We have important remarks. In the two right-angled triangle, the two right-angled triangle are congruent if two sides of the right angle in one of them are congruent to the corresponding parts in the other triangle. The hypotenuse and the other angle except the right angle in one triangle are congruent to the corresponding parts of the other triangle. The hypotenuse and the other angle. Aside and the angle, aside and the angle except the right angle in one triangle are congruent to the corresponding parts of the other triangle. If each angle of a triangle is congruent to the corresponding angles of the other, it's not necessary to it's not necessary for the two triangles to be congruent. We have a case. It's three sides. It's side. Three sides in the first triangle are congruent to the corresponding parts of the other triangle, but it's not necessary to that the two triangles are congruent if the three angles in the first triangle are congruent to their corresponding parts in the other triangle. We don't have a case with three angles. We have a case with three sides, but we don't have a case with three angles. If the two angles of the triangle equal to angles in the second triangle, then the third of the first triangle equal to the third of the second triangle. Two angles of the triangle equal to, it's not congruent triangles. So triangles are not congruent, but the equal angles, two angles equal the two angles in the other triangle. Then what? Then the third angle will be equal to the third angle. But we can say that the two triangles are congruent. This case just for to find the third angle, the measure of a third angle. Two triangles, we have if measure of angle B equal measure of angle Y, and the measure of angle C equal measure of angle Z, then measure of angle A will be equal measure of angle X. But the two triangles are not congruent, not congruent. So today we have studied the congruent triangles. From the first, we say that that any two polygons are congruent if the if all sides and all angles in the first polygon are congruent to the corresponding parts in the second polygon. And we talk about the special cases of congruent is a triangle. We have a special cases for congruent triangles. It was four cases. First case is side angle side. We say that the two triangles are congruent if two sides and the included angle are congruent to the corresponding parts of the other angle of the other triangle, so the two triangles are congruent. In the second case, it will be angle side angle, and we say that the two triangles are congruent if two angles and side drawn between them of one triangle are congruent to the corresponding parts of the other triangle. And the third case is side 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 S. The two triangles are congruent of if each side of the triangle is congruent to the corresponding sides of the other triangle. And the last case, and it's just for only the right angled triangles. The two right angled triangles are congruent if the hypotenuse and side of one triangle are congruent to the corresponding parts of the other triangle. Now we finished our lesson. Thank you for your listening and see you in the next session.